I'm going to go through this question in two different ways. First of all, really neat and quick way. So I'm going to consider two different cases. Shading, like imagine we're shading two triangles, but we're going to shade them one at a time. So the first one I'm going to shade is going to be on the outside. And without loss of generality, I can say it's top left. Bottom right will give me exactly the same probability, and I can imagine rotating the shape and then it would be top left. So it really doesn't matter. Now, if I shaded top right, then I'd get a line of symmetry down the middle. If I shaded bottom left, I'd get a line of symmetry going across. So both of these would work. And this one would also work. I'd get line of symmetry diagonally, as I would if I shaded here or here. So these five are the possibilities um, when I shade the top, or any outside triangle first. There's actually a 5/7 chance of then getting at least one axis of symmetry. Now that's not the final answer because we just need to check now if we shade one of the inside ones first. So again, without loss of generality, I'm just going to say it's this one here. So now if I shaded this one or this one, I'd get an axis of symmetry, as I would again down the diagonal. So again, there's a 5/7 chance. And if we put it together, then we see, right, it doesn't matter what one we shade first. You're going to either get one on the outside or the middle. And then once you've shaded a second one in, there's necessarily going to be a 5/7 chance of having at least one axis of symmetry. So I don't need to add them or times them or anything. That is actually the final answer. We just split it into these two cases, outside, inside shaded first. In both cases, there's a 5/7 chance, which means that's what it is overall. On to method two. So method two, more carefully, I can more carefully listed and drew all the different ways of shading in the grid. It works, it's just a little bit more involved. Okay, here goes. So let's imagine that we shaded um, these two. Then we'd get an axis of symmetry, and there are four ways that we could select the corners that are sort of next to each other. So I'm just going to keep a running total of that, and all of them would have an axis of symmetry. What I mean is we could have this one and this one. That would be another way. This one and this one, or this one and this one, and that's it. And so I've included all of those cases. Right, now let me shade this bottom left one, and then this one here. Now again, there's going to be four ways I could pick a corner, and then one that's like sort of on the opposite side. For example, this one and this one. So there's going to be four ways for that, and they're all going to have a line of symmetry. Okay, and then I'll go with bottom left again, and then what about the very opposite one? So this time, there's actually not going to be four ways. There's going to be two ways. I could either pick bottom left, top right, or bottom right, top left, if I'm getting this configuration. And again, that will have an axis of symmetry. Okay, right, let's move on to something else. What about these? Okay, this doesn't have an axis of symmetry. And what I could do, if I'm picking one of the corners, and then I'm going to I could like instead pick for bottom left, I could pick this one as well. So that would be two different ones where I don't get an axis of symmetry. And then if I think about the other corners, they're all going to have two as well. So overall, there's going to be eight where there isn't an axis of symmetry. Okay, bottom left. And then what about this one? That is again going to work. And if I pick a bottom one and pick the one that's like basically adjacent to it, then they will all work. So there's going to be again four ways with all with axes of symmetries. Okay, I've actually gone through having ones at least one on the outside. That is all the different cases because I've had bottom left and then I've dealt with that one as well and that one. I've dealt with this one and this one, and then I've dealt with the cases where we don't get an axis of symmetry. So it's all accounted for, which means all I need to do now is look at what happens when they're both on the inside. So I could pick this one here and then this one here. And there's going to again be four configurations where I'm picking ones on the inside. These two, or these two, or, oh, sorry, I didn't do that, or these two. So again, four ways. And that just leaves picking this one and then this one. And then again, there's going to be two ways because I could have these two instead. Okay, nice. I've actually written down all the different configurations. So let's add them up. We've got 10 here. We've got 12, 16 here, 2 here. So overall, there are 28 different configurations. How many of them have at least one axis of symmetry? Well, it's going to be all of them except 8 of them, actually, which gives me 28 minus 8, 20. There's a common factor of 4, which cancels down to 5/7. So like I said, more involved, but it's quite nice, writing them all down. There's not too many. You can see in a problem where, there's even more configurations, like this method definitely comes into its own and would work really well, but both, they complement each other, and I like both of them.